If you have access to the subdivision limit surface by patch IDs and the patch UVs, then surely you can scatter points on the subdivision limit surface just like you can scatter points on a polygonal surface. And this is exactly what we are gonna do in this chapter. Continuing from where we left off, clean up some of the nodes. Create a scatter node and connect this to the first input of the limit surface sample subnet. As you can see, all the scattered points are projected onto the subdivision limit surface, as well as getting the colors and the normals from the subdivision limit surface, without doing any changes. Instead of using the minimum projection option, you can use the equivalent options in the scatter sub. Just rename them to limit prim and limit prim UV to match the limit surface sample internal attributes. As you can see, we get the exact same result. And with that said, see you guys in the next lesson. This time, instead of using the scatter sub, we will generate a point cloud directly on the subdivision limit surface. We will use the OSD lookup face function to get the face ID and UV coordinates from the given OpenSubdiv patches. The code we will write is based on the example code in the OSD lookup face function help card. So create a box and point normals first. Now create a detail wrangle and connect the box geometry into the second input. Get the target point count from a spare parameter. We need to figure out the patch count using the OSD patch count function. Declare variables for face ID, face U, V, and point position. We won't be using these though. We just need to pass these to the OSD lookup face function. Create a for loop from 0 to point count being exclusive. The code sample was using nRandom, which is a non-deterministic random function, so we will just use that. In production, you don't really want to use that, as the random values will always be different than the last time they were evaluated, so it won't match the previous results. This is more useful for interactive applications like games. So pick a random patch using nPatches and nRandom, and cast the result to int. We create two more random values for U and V respectively. Pass all of these to OSD lookup face function and use the second input. The code sample is using the UV as the texture attribute, which is the same as the intrinsic polygon interpolance. So if you left this out, the result would exactly be the same. If the function succeeds, we get 1, otherwise 0. So use this function inside an if statement like before. If we successfully look up a face, then we evaluate P on the subdivision limit surface using the OSD limit surface function. Again, use the second input. This gives us a point position. Create a point at this position and store the face ID and the patch ID on the new point. I will set point count to 1 million. Color the points using the face ID attribute. I'm just going to merge the points with a slightly smaller subdivided geometry to remove the back-facing points from the view. Because all the polygons are quads and none of them have extraordinary vertices, the face IDs and the patch IDs are the same. Let's try it on a tetrahedron. As you can see, the face IDs and the patch IDs are quite different. Once you visualize the patch IDs, you can see that they are a lot more than the face IDs. It is really useful to see the differences between them for different types of geometry to better understand OpenSubdiv patches. And with that said, see you guys in the next lesson.